Hello, folks. Welcome to my channel, Number Pen. Today, we are going to solve a few problems on the topic limits under differential calculus. So, you saw in my earlier video the topic on continuity of a function f of x at x equals a, right? And we did discuss about what we mean by continuity. When there is no break or jump when you draw the graph of a function at any point, right? Then you say that the function is continuous. Now that's the English meaning. And when we spoke about the mathematical definition of continuity of a function, we did bring about a topic called limits. And before we move to discussing problems on continuity of a function, I thought we'll spend a few videos working out problems on limits. So we did come across this statement yesterday where the function is said to be continuous when f of x tending to a plus, which is known as the right hand side limit, which means that x takes a value which is slightly greater than a, and by a number called h, and h is infinitesimally small. And similarly, you have your left hand limits where x takes a value which is smaller than a by an infinitesimally small value h, and both these values will have to be equal, and they'll have to be equal to f of x at x equals a, um, for the function to be continuous, right? So today we're going to look at a few more problems on limits, right? You will see a lot of competitive exam carrying problems on limits, and I thought a few videos on this topic will help you understand this topic better. So I've got a few problems here, and I want you to take a close look at problem number 15, which we have here on our screen, which is find the limit as x tends to 2, x minus 2 divided by x squared minus x minus 2, right? So when you look at this problem, what is it that you are actually being asked to find? You've not been asked to find the value of this function at x equals 2. So you will have to understand that what you've been asked to determine is the value of the function as x gets closer to 2. It could be closer to 2 from the left hand side or the right hand side, and that is what we mean by x tending to 2, right? Yeah. So what we need to find is as x takes a value which is getting very close to 2, what is the possible value of this particular function, which is x minus 2 by x squared minus x minus 2. So for a minute, let's substitute this equation with x equals 2, right, and see what we are getting, right? So we have 2 minus 2 divided by 2 square is 4 minus 2, which is the numerator is 0 and your denominator is also 0, which means it takes it becomes an indeterminate, right? So but what if it takes a value which is very close to 2, and I want you to also try this out with your calculator, right? Replace 2 by 1.999. Let me try this out. 1.999 minus 2 divided by 1.999, the whole square. So let me use the symbol here, minus 1.999 minus 2. Just give me a minute, let's calculate this. You will see that when you work this out, you'll get an answer 0.333. You will see that when you work this out, you'll get an answer 0.33344, right? And the Means when x equals 2, it becomes an indeterminate, whereas when x takes a value which is very close to 2, it still has a finite number, right? So, what is that number is what we are going to try and find it out, right? And you might want to check or cross check your answer using the substitution method, substituting a number which is very close to x equals 2, and seeing whether this works out for you, right? So, let us understand how to solve this problem, right? Now, x minus 2, I can rewrite my denominator. I'm going to factor this further, and you'll see a lot of these problems we apply this technique of factoring a particular function or an equation, right? So what happens to this is you still have your x minus 2. I'm going to rewrite this equation in the denominator as x minus 2 into x plus 1. Are you there with me? Which means I'm left with a common factor, which is x minus 2 in the numerator and in the denominator, right? So all that I can do is just strike through, or rather cancel x minus 2. So let me use a control D and cancel this out, and we are left with 1 divided by x plus 1. So now we go back to the calculation of the limit, right? Now when x takes a value which is very close to 2, which means that it could be a 2 plus h or a 2 minus h, where h is infinitesimally small. I'm going back to this. Let me highlight this. I'm going back to what we discussed in the beginning of the video, right? Highlight this. Yeah. So, which means that f is equal to f of x equals 1 by x plus 1, which is equals 1 divided by 2. Let me try this out with 2 plus h plus 1 equal to 1 by 3. So this is what is the limit of this function as x takes a value which is very close to 2, right? And let me do one thing. Let me check this out by substituting 1.999, which is a number which is very close to 2, and let us try it out using 2.001, right? So we do this without any factoring, right? We do this right from this equation without factoring it or making any cancellations on f of x, right? And that is how we arrive at this answer. So I get 0.333222, right? That is what I get uh, when I make a substitution. So which means for values which are very close to 2, let it be on the left hand side, be it a number 1.999, or be it a number on the right hand side, which is 2.001. we get a number which is very close to 1 by 3, uh, which is your limit of this function, right? So existence of a limit does not necessarily indicate continuity, and I don't want to touch upon this topic right now, but all that we need to know or we need to understand is the limit, be it the left hand limit or the right hand limit, as x tends to approach a particular number, say a, will have to be equal for us to conclude that a limit exists, right? So we will solve similar problems in the rest of the video, and I have listed down a few simple problems. Many of these problems are very simple, and I just wanted to take you through them so that you get an understanding of limits better. So I'm going to rewrite this equation. So we have limit x tending to 2. What is uh, x minus 2 divided by x squared minus 4? What is the limit of this function as x tends to 2? Right? I'm going to factor this. We know x squared minus 4 square is nothing but my square minus 4 is nothing but 2 square, right? I rewrite this, a square minus b square equals a minus b into a plus b, right? So I rewrite this again, and I'm gonna write this as x minus 2 into x plus 2, which is nothing but my x square minus 4. And I'm gonna strike through x minus 2 in the numerator and x minus 2 in the denominator. Which means I'm left with 1 divided by x plus 2 as x tends to 2. Now, in the previous problem, we did a 2 plus h, right? Now, let me do a 2 minus h here, right? 2 minus h plus 2. And I'm assuming x takes a value which is slightly lower than 2 by h, and h is infinitesimally small. So, which means our limit is 1 by 4, right? And let me assume that x takes a value slightly higher than 2, right? I still have my denominator becoming 2 plus h plus 2 and h tending to 0. I'm still left with 1 by 4. So that's the limit of this particular function as x tends to 2. Remember, folks, this is not the value of the function at x equals 2. It is the limit of the function as x tends to 2, which means that what is the value the function takes or tends to take, as we go very close to 2. Have another similar problem where, we will use the technique of rationalization here. So x tending to 0. Again, as you substitute x equals 0, it becomes a 0 by 0 indeterminate form. But is it so when it takes a value which is very close to 0 is what we are going to determine by finding out the limit of this particular function, root of x plus 3 minus root 3 divided by x. So I'm going to rationalize the numerator, and give me a minute before I tell you what exactly is rationalization. I'm going to multiply the numerator and the denominator by the same number. So this is what I have. What I've done is I've multiplied by the numerator by root of x plus 3 plus root 3 and the denominator by root of x plus 3 plus 3. And you see that the numerator takes the format a minus b into a plus b, which is nothing but your a square minus b square, right? So copy this. So we've used the formula a square minus b square equals a minus b into a plus b, which gives us the numerator to be root of x plus 3 the whole square minus root 3 square, right? And so I'm going to rewrite this in the next line, which is my x plus 3, my root of x plus 3 the whole square becomes x plus 3 minus 3, which is my root 3 the whole square divided by this, right? So this is what we are left with, and I'm going to write this again as x divided by, I hope you guys got what we're actually trying to do. X plus 3 minus 3 becomes x, and you're left with x in the numerator and x in the denominator, along with root x plus 3 plus root 3, right? So what happens, I'm going to cancel, use strike through so that it's a lot more clear. So we have cancelled x in the numerator and the denominator, and we are left with 1 divided by root of x plus 3 plus root 3, right? And as x tends to 0, you will have this as 1 divided by 0 plus h plus 3, and as h is 0, we will have this equals 1 divided by 2 root of 3, right? So there we have our final answer, which is your 1 divided by 2 root 3 is your final answer, right? We'll look at one more problem, again based on rationalization. So let me rewrite this again in a very similar manner how we wrote the equation earlier. To divide this again by root of 1 minus x plus 2. plus 3. Do something very similar to what we did in the previous problem. I'm multiplying the numerator and the denominator by root of 1 minus x plus 2. And since you're multiplying the numerator and the denominator by the same number, it does not change the value of the limit as x tends to a particular number, right? So root of 1 minus x minus 2 into root of 1 minus x plus 2. And I'm going to rewrite this in the next line. It becomes 1 minus x minus 4, because it's root of 1 minus x the whole square minus 2 square, which is nothing but 1 minus x minus 4 divided by, I'll keep this as it is for the time being, and which means my numerator is minus x minus 3, because 1 minus x minus 4 is minus x plus 1 minus 4, which is minus 3, and means it's nothing but minus x plus 3 whole divided by this, right? So again, I have my x plus 3 cancelling out in the numerator and in the denominator. So let me strike through this. Let me strike through this, right? And we are left with minus 1 divided by, as x tends to minus 3, this becomes minus 3 plus h, right? Which means I'm left with minus 1 divided by square root of 4 minus h 2 plus square root of 4 minus h, which is nothing but minus 1 by 2 plus square root of 4, which is minus 1 by 4. So that's the limit of this particular function, right? So in all these equations, right, you see that as x takes the value minus 3, the function takes an indeterminate form, right? Like, for example, when I substitute minus 3 in this equation, what you see on your screen, you will see that it takes a 0 by 0 form, which is indeterminate. But when it takes a value which is very close to minus 3, it still tends to a number uh, which is minus 1 by 4, right? And you can test this out again, like I mentioned earlier, substituting any value which is close to minus 3 in this equation, right? But not minus 3. So it means that, and in all these equations, when you work out problems on limits, I think one thing you should simultaneously uh, do is, it doesn't matter whether you substitute uh, is as a plus h or a minus h, right? But one thing you'll have to be very clear about is, whether a plus h, the value at a plus h and the value at a minus h is the same, right? Now, if these values are different, then it means that the function does not have a limit, and you will see in the subsequent problems that we solve, we will come across some examples like this, right? So that's all we have in this video. I hope you had a good basic understanding of how to approach a problem on limits. And look, please stay connected to my videos. If you like my videos, please do subscribe. Please pass on your feedback. Happy to receive comments on any of the videos. I have submitted about 15 videos now. Have a good day. Thank you for watching my channel.